Okay, hello students. The first numerical, um, which we started yesterday, I think we finished till step one. Part one of the video is uploaded on YouTube. You can check it out. Well, the link is in the edit. Right. So this numerical we were solving in the previous class. Right. So we'll continue this. This is the first numerical on Bevel gas we solved, or not yet solved, but it's still underway. This is the first step. Noted the data. Step one was to find the weaker member. Since both the pinion and gear were of the same material, we chose pinion as a weaker member, and all other data were given. N2, Z2 were found. Delta 1, delta 2, which are needed for step 4, they also were found. And finally, the virtual guess. By using the data of virtual number of gears, we found the data for actual number of gear tooth in case of the bevel gears, right? So we'll start off with step 2. Step 2 is to module M. Right? That's the objective of step 2, and this is split into two parts. That is the tangential tooth load. That's tangential tooth load. The tangential tooth load, we'll use a generalized equation. We'll go back to the data handbook, and we are doing step 1 is done. This is step 2, right? Step 2, first thing you need to note down this formula, which is in equation 12.7a. So Ft is 1000 PCS over P. Let's note down this information here. Okay. So this is F subscript T equals to the this thing 1000 P, then C subscript S over V. So this is the generalized form of equation 12.7a, available in the data handbook. This is mahadevan. Right, so we'll note down what is given. P, I think, is given in the question, and the data 30 kilowatts. There is 30 kilowatts. Then CS is the service factor. So service factor is depending on number of hours of usage. So let's go back to the PPT. So service factor, I think type of service is not given. So let's just assume some value here. So let's assume this continuous 24 hours and medium shocks. This is from table 12.7. So let's assume just continuous 24 hours per day and medium shocks. So we'll take 1.8 value. This is 1.8. This is assuming 24 hours per day and let's say medium shocks. we are assuming, and this data we get it from table 12.8, right? So finally, velocity, we know the equation. So go back to our PPT. So we use this. So by heart, this is not given in the data handbook. So pi dn by 60,000. So let's use pi. Here the weaker member is pinion, therefore we'll use d1 and n1 over 60,000. Okay, so this d1 and n1. Why? Because the weaker member is pinion. So since the weaker member is pinion, you'll use the subscript 1. So whichever is weaker member, you use that particular data. So that means there is pi times d1. So d1, do we have d1? No. So instead of that, we need to modify the data as m times z. Okay, so this is instead of d, we'll use m z1, where d can be written as mz1. So since we don't have d, and we are also finding m in this step, we just modify this form. So this is equal to pi into m into z1. Number of teeth z1, I think is right 24. There's 24 into n1. So n1 was 900 rpm. So 900. So to simplify this, then we can use it in the equation ft. Now our ft is, to simplify this, post it in the group chat. Power p is 30 kilowatts into cs is 1.8, and what is v in terms of m? So velocity is pi into 24 into 900 over 60,000. Okay, you are getting 1.13 m. We'll use this here in finding the tangential tooth load. So this condenses to some value in the numerator over m. So that value, try to find out, post in the group chat. We'll move on to part B. Part B of this step 2 is tangential tooth load using Lewis equation. The Lewis equation, we'll go back to the data handbook. Right, so this is our part B. There is a Lewis equation given in the data handbook, equation 12.37. So let's note down this value: sigma d cv dy m. So again here, this ft is equal to sigma d, sigma d. Then again we have cv. Copy this. CV and B capital Y M then into we have L minus B over L. This D is a subscript, right? So this is equation 12.37. So this is in data handbook 12.37 equation. Okay, so let's note down one by one here. Sigma D here we use it for it's common anyway here. We'll note down the same value. Sigma D is 345.2. Then CV. CV is the velocity factor. Right. So let's check it out. So CV you will calculate from equation 12.38 to CV. Let's see where is right. So this is where we get the CV. There is a velocity factor for bevel gear. So this is given in terms of form, which how it is manufactured. So for this is by form cutters and generated teeth. So then in the question it is clearly given it is by form cutters. So we'll use this equation here. So by 12.38a. So since in the question it is given as form cutters, we'll use 12.38a and note down this equation CV. Okay. So this is 3.05, right, over 3.05 minus V minus a plus. This is plus, right? So this is from equation 12.38. So this gear is done by form cutter. So therefore, use this equation here. So let's simplify this. So V here is what is V found before 1.13, 113, 1.13. Right. So we have our CV. Next is B. So B is go back to the handbook. So B is 10m, referring to these equations. We have it here. Right. So referring to these equations here, so we'll take it as a generalized value. Is up to 7 to 10m for whichever it is. So it's almost greater than or equal to 10. We'll keep it as 10 itself as a standard. We'll keep it as 10m, just like per gear. What else is required? So we have the y. Y is again given in the just below the equation. It is 10 times pi times y. Y is pi times y. Capital Y equal to pi times y 1. So why the subscript 1 is because the weaker member is pinion. 1 is with respect to the pinion. Therefore, we'll put that. So this is pi into y1. What is y1? The y1 is 0.088. 0.088. So it gives us how much? 5 times and 0.88. 0.275. So keep this. So we have y m is required L. Only L is required. So for L, let's go back to the presentation. All right. L is nothing but the cone distance. So L will note down either of this formula. So we don't have D. So again, you need to write it in terms of M and Z here. right? So since we don't have that value of L, you need to write it as M and Z. Okay, so any one. So let's note down this last one. So whichever is feasible. I think this one good enough. D1 over 2 sine delta 1. This is 12.33. So this is equal to is D1 over 2 sine is delta 1. Okay, so this is a subscript. This also is a subscript. Okay, so let's substitute this values here. So this is equal to D1. We can write it as again MZ1. Okay, since we don't know the diameter, we're writing in terms of M and Z, and over sine 2 sine delta 1, this value. Now let's substitute here. This is equal to Z1 is 24 to 24 over 2 sine delta 1. This delta 1 is 8.95. So delta 1 is 8.95. So this comes around 24 over 2 sine 8.95. This is 77.1313 m. Right. So now we have all the values which are required for our tangential tooth load. Using this Lewis equation, and also from the first part we need to finish this. Anybody got the value? You can post it in the group chat. It is 1000 times 30 times 1.8 or 1.13. Okay, so this I'm getting around 47787.61. Right. So I'll copy this. This is part 2 of our tangential tooth load, step 2, part 2. Let me substitute everything here. So FT I'll copy from the step 1, part 1 of step 2. This is FT from part 1. Then this is equal to this whole thing here. So sigma D, 1 by 1, let me substitute. 345.2. Sigma D is 345.2 times CV. CV is this whole thing here. Insert bracket. This whole thing. Into CV is done. Then into B is 10m. Then into Y is 0.275 from above. M into L is 77.13 m. Into B is 10m. Then this is 77.13 m. Right. So we have substituted everything, whatever we have found, and the individual steps here from the data handbook we have substituted. Now let's simplify. Simplify this. Objective is to find m here, module. So this equals okay, let me multiply all the numerators here. You can solve parallelly along with me and find out the value. 3.05 into 10 to 0.275 into 7.6. Okay, so what I've got here is 2519.98. M is 1234. No, just 1 2. M square over I think only this remains. This part remains. Okay, you can post in the group chat when if you are calculating your homes. This M cancels out, so right. So simplifying further, so this thing I'll get as 47787.61 times 3.05 is 14575.21 plus this is 1.13, getting 53, let's say 54. Okay, let me say 53, 9, 54123 M equals this 592,519.98 is no longer M square, is M cube. M cube. Okay. So solve this using the equation equation mode in your calculators. So its degree is 3. So A value is 12519.98, B is 0, C is 54000, and D is 145. Oh, negative. Forgot negative. C is minus 454123. Minus D is minus 145752.21. Okay, so right. So module I've got 5.63. Okay, you can check if you got this answer and you let me know. So that means I can approximate it to 6. A module I found. Right. So this step is done. Step 2 is done. Objective is to find the module. So we have found the module. Module M is 6. Right. Okay. Next we'll move on to step 3. Step 3 is tooth proportions. That is the dimensions of the hair tooth. So here from the exam point of view, you can find any few dimensions. You're not required to find all the dimensions here. So let's find few key dimensions. Let's say the pitch diameters and say addendum and dedendum for gear and this for gear and pinion. So addendum, dedendum, and then we'll find for the diameter. So let me say D1. Where is D1? D1 and D2. We'll find D1 and D2. So D1 is MZ1, right? We have found the module now, which is 6 times 24. Okay, this is nothing but the pitch diameter. Pitch dia. Let's see. Pinion. Okay, so similarly, pitch dia of gear. Next step. This is D2 Z2 is equal to 6 times 24, not 24, what is Z2? Z2 120. So 120, right? So with this we'll get the two diameters. Then addendum of pinion is given in the here. Pinion is 1.4 times module M. Find that, and similarly addendum of gear. Addendum of gear 1 point, not 1 point, 0.06 times module. We find that also. Similarly, it didn't. Only key dimensions. Let us find. So addendum is 0.7571. 0.7571 M, and this is 1.5571. 1.5571 M. So all these are just key dimensions. You can find just by multiplying the given value with the module. So 6 times 24, 144 mm. Then this is 120 times 6, 720 mm. Okay. All these we can find out individually. Then we'll move on to next step. So step 4. Step 4 is dynamic load. So step 3 is just plug and play. So step 4, the dynamic load. So this equation here is FD is a dynamic load. Is this equation here? It's like this. Okay, this is FD is a dynamic load. Subscript. This is equal to FT plus, we have a fractions, K3 V, then bracket C B plus F D. Okay, so this K3 is a substitute. So this formula you can see it is similar to the one which we use for spur gap. KV3 into square root of this whole thing. Right. So this is equation 12.40. This is for the bevel gear. And again here we'll note down the values individually. So Ft will find the individual values of each. So Ft here is equal to, you can copy this value here. We're not yet found Ft, so we'll find it from part step 2 part 1. This is module we have found out now. So module here we know is 6. So that's equal to how much you can find out post in the group. Next, K3 is by default given just under the formula. K3 is given just under the formula. It's 20.67, and V velocity again is dependent on module, so we'll take out that data also. Where is velocity? Yeah, here 1.13 m. It is 1.13 m. This is equal to 1.13 times 6, and C is tricky. So C, you need to use these two tables as discussed before, right? So we need to know the error. It is made up of cast steel. That is, you can say combination of steel and steel for 20 degrees. But you need the value of error here, right? So the class of here is given. It's the precision cut. So if you check the question, so this question is given that the here is precision cut by form cutters. So it is precision cut, and for module 6, the value is 0.0172. This is the error. Okay, so we'll note down that. Say for error equals how much? 0.0172. 0.0172. So that's the error. Check back in the table 12.12. Is there any 1.17? So it is in between, somewhere in between here, 1 and 2. 0.01 and 0.02. If you want, you can interpolate and you can find the value. So let's interpolate. So for x 0.01 and between 0.02, we need the value for 0.0172, right? So it is 0.0172. 0.0172 for form gears, steel and steel, 114.4. So x1, y1 we have 114.4, and 0.02 you have 228.9. 228.9, right? So now we interpolate. To know how much do we get. So this value is 114.4. This is 228.9. Then again 114.4, and this is 0.02. Wait, this minus 0.1, and this is 0.1, and this is 0.2, right? Right. So if we interpolate this, what do we get? So let's do this. 0.0254, 254, not 254, 0.0172. 0.0172. Okay. 0.0172 minus 0.01 over 0.01 into 228.9 minus 114.4 plus 114.4. Okay, you're getting 196.84. So you can also approximate this. You feel this is lengthy by doing this approximation. No, you can put somewhere in between. You can take 200 or 195, some value, and approximate. This is not mandatory. So see, we have got from interpolation, it is this much. Then we have FT, we have so everything we have. We have all the data. We can go ahead with the substitution. Oh, B. What about B? We don't have B. So B is 10M. So 10 times 6 is 60 mm. Right. So now we have all the data. We can go in for substitution. So FT we have found. Oh, they're not. Everybody found FT. If you parallelly calculate, it will be sooner because I need to do calculation, and right now it will be lengthy. 0.6, right, newtons. Hmm. 7964.6 newtons. K3 is 20.67 into V. V, everybody found V. 0.13 times 6, 6.78 meter per second. So this is 6.78 times C is 196.84 times 60, and FT we have already got 7964.6. Okay, so let me just copy this. So it is K3V, this is in the denominator also, K3V, then CB plus FT. So all this is there. You can calculate and tell me the value. So after this, the last step, F5, which is wear load. We are doing this to find DHN, the hardness. That is using the wear load formula. Right. We'll go back to the PPT. The dynamic load is done. So this is the wear load. Last step. So wear load is this D1 VQE K over cos delta 1. Let's type this. So FW equals D1 VQE and K over cos delta 1. Then we put some here in terms of subscript. This D1 QE. So this is where that number of virtual teeth come into picture. Number of actual teeth, that is for the bevel gear, come into picture. That is ZD1 and ZD2, which we found in the first step. Right. So here let's take this one by one. So D1 I think we have found in the third step. D1 is 144 mm. 144. B is 60, also found in the previous step. Then QE. So QE here is the factor for actual number of teeth. This can be given as 2 times ZE1. Okay, let's check ZE2, ZE2 not 1 over ZE2 plus ZE1. Okay, so this small correction you have to make. All the previous times we found ZQ by using the actual number of teeth or the virtual number of teeth, but here it is using the equation here. Okay, so 2ZE2, so 2 into ZE2. Let me go back to the first step. ZE2 is 191.25. This is 191 and 191 plus 25. Okay, so calculate this, then cos delta 1 we can find it out there, right? So everything is found. So let's find FW. So D1 is 144 into B 60 into QE. Anybody found? Post with the group chat. 2 into 191 over 191 plus 25 is 1.77. Okay, so this is 1.77 K over delta 1. Delta 1 is cos delta 1. Delta 1 is 8.95, right? 8.95. Right, so from this we'll get our FW. So let's calculate this. 144 into 16, 1.77 over cos 8.95. We have a 1548.3, 481.3, 1.3 K. And now for safety, for safe design, this is a condition. So FW should be greater than FB, right? So FW, that is the wear load for the tooth, should be greater than this FD here. So anybody found out FD? Post it in the group chat. So this should be greater than how much? To calculate 796,964.6. Let me work backwards. 796.4.6 plus 60 into 196.84 into 6.78 into 60.20.67. This is divided by 0.67 into 6.78 into under the root 196.84 into 60 plus 7964.6 in this plus 7964.6. Right, so I've got 8048, 8049 almost, but your answer also works. So let's take your answer, 8105 newtons. Okay, 8105 greater than 8105. So K here should be greater than this 8105 over 1548 1.3. This is 0.5235. Right. So we have got K as 0.05235. For this, let's see what is the recommended hardness. Okay. So for 20-degree K value, 5235. 52, I think it's closer to this value here for 20-degree, and combination of steel there is 250 and 150. 250 and 150. So that is the recommended hardness here. 0.5. Let's go back. So let's wind up. So BHN from 12.16, and for K, BHN for pinion equals 250 and 150. 250 for pinion and BHN for gear is 150. Okay, so that's it. This is the end of the first problem on bevel gear. Any doubts you have, you can post in the group chat, or let me know if some step is wrong or something is missing.